All right, in this particular problem, what you want to be able to see is that your highest power of x is exactly double your other power of x. So this fits the of quadratic type, which indicates to us that we're going to use u substitution. So if we let u equal the smaller power, so x squared, then that means that u squared is going to be x squared squared, or x to the fourth. And so by substituting these values in, we get 4u squared minus 29u plus 25 is equal to 0. And so we now have a quadratic equation that we can solve. So when we look at this, if you notice that your first and last terms are both perfect squares, and you can check to see if you take their bases, 2u and 5. If we take the product of those bases and double it, do we get this middle term? No. So it's not a binomial square form, okay, but that's something that you should check first when you notice your first and last terms are perfect squares. And so we either are going to need to rewrite this as the sum of terms or reverse FOIL. And the reason I'm going to reverse FOIL is I noticed something about these numbers. Okay, I have 4u and I have 25. Well, when I look at these, I know that my product is positive, so the signs are going to be the same. My overall sum of the outer and inner products is negative, so I know those signs have to be negative. So right away, my foiling cuts in half what I need to test for. I know the signs. And then when I look at this, 4 and 25 add up to 29, right? So I know that if I just put those on the same one and I test, I get negative 4u minus 25u gives me my total of minus 29u. And so you can find it in a quicker fashion that way. Okay, so this gives me two values for u. If I take my factor and I set it equal to 0, okay, my first factor will yield the opposite of the constant, so positive 25 over the coefficient 4. And my second one is just a value of 1. So those are my two possible answers. If I set my original, if I move back to my u substitution and I set what u was originally equal to, which is x squared, equal to each of these, 25 over 4 and 1, and I solve the resulting equations. Okay, extract the square root. When I extract the square root, I have to take into consideration the positive and negative root. And here, square root of 25 is 5, square root of 4 is 2. And extract the square root here, I get x is equal to plus or minus, again, take into consideration the positive and negative root of 1. And so I wind up with 4 different solutions, plus or minus 5 halves and plus or minus 1.